So this final video of the year, okay, we are going to be looking at first 14.6, which is on page 692, and the focus is the inverse cosine and sine functions. Now, what's important about this to note is that trigonometric functions, so sine and cosine, for example, are periodic. For example, cosine of pi over 3 is equal to 1/2, which is also equal to cosine of 5 pi over 3. And cosine of 2 pi over 3 is equal to negative 1/2, which is equal to cosine of 4 pi over 3. You can double check those numbers on your note card. And what's important about noting this is that there's more than one place where cosine is equal to the same function. And in order to have an inverse, this can't happen. So what we have to do is we have to cut or limit the domain of cosine and sine. That way we can have an actual inverse function. So that's what the definitions do down here. It says that sine inverse of y, they capitalize all of their, so you don't have to, is equal to x, where x is an angle, for when x is in between negative pi over 2 and pi over 2. This is going to throw off a lot of you, okay? That means we are in quadrants 1 and 4, and then we have negative pi over 2 and 0. So we move in the negative direction here and in the positive direction in quadrant 1. So before, when 11 pi over 6 would be your answer, it's actually now going to be negative pi over 6, okay? And that's going to throw off a lot of you, so you need to make sure that's sticking. Secondly, cosine inverse of y is equal to x, where x is an angle, for when x is in between 0 and pi. So the nice thing is that for cosine, you're only moving in the positive direction. Okay? So let's look at a couple examples. For number 2, we want to find cosine inverse of negative square root 2 over 2. So first thing I want to do is set this equal to x and solve for that x. So I'm going to rewrite this as cosine of some angle x is equal to negative square root 2 over 2. So then you need to look at your note card and see on the unit circle where cosine is equal to negative square root 2 over 2. You should get that x is equal to 3 pi over 4 and 5 pi over 4. 5 pi over 4, though, is greater than pi, so it's not in the interval. So it's not a choice. So our only answer is x equals 3 pi over 4. For 6, we have sine inverse of sine of 3 pi over 2. So by definition of inverses, sine inverse of sine 3 pi over 2 is just equal to 3 pi over 2. It's like taking x times 1 over x. Okay, they kind of cancel each other out. But the only issue is that 3 pi over 2 is not in the interval of negative pi over 2 to pi over 2, right? Because 3 pi over 2 is larger than pi over 2. So what we're going to do is subtract 2 pi from it. We'll get negative pi over 2. This is now our answer. For 10, we're looking for cosine of sine inverse of negative square root 3 over 2. Remember that sine inverse of a trig value will give us a theta. So really they want us to find some cosine of some theta without telling us what that theta is. But they actually did. They just didn't give it to us in degree term. So we know that sine So what we're going to do first is find the theta value. So sine of theta is equal to negative square root 3 over 2. This would be in quadrant 4, since we're dealing with sine inverse. So we have negative square root 3 and 2. Use Pythagoreans to do 4 minus 3 is 1. So our cosine of that same theta is just going to be 1/2. For 16, we have cosine of sine inverse 1/2 plus cosine inverse of 1/2. So I'm going to name this first sine inverse as alpha angle and our beta angle. So really we're looking for cosine of alpha plus beta. Okay, and so I'm going to draw my triangles. I'm in quadrant 1 for each of these, right? Because they're both positive here. So I've got 1, 2, and then 1, 2. Pythagoreans tells me that this is going to be square root 3 and square root 3. And what's nice is that this matches a triangle where alpha is pi over 6 and beta is pi over 3. So I'm going to replace alpha with pi over 6 and beta with pi over 3, and you can double check those answers from your unit circle. So I get cosine of pi over 6 plus pi over 3, get a common denominator of 18, of 12. This is 2 pi plus 4 pi over 12 equals cosine of 6 pi over 12, which is cosine of pi over 2, which by the unit circle is 0. Now let's look at 20. In 20 we have cosine of 2 cosine inverse of x. So really they want us to find the value of cosine of 2 theta, because theta is cosine inverse of x. So I'm going to draw a triangle to match with my cosine inverse. So they told me I have cosine inverse is equal to x. That means I have adjacent, which is x, over hypotenuse, which is 1 for our theta. So to find our remaining side, we're going to do Pythagorean, so it'll be 1 minus x squared. So I need to figure out how I'm going to find cosine of 2 theta. And so what I'm going to do is use double angle formula, which we just learned. And it's 2 cosine squared theta minus 1 is the version I'm going to use because we already have cosine theta, so it's a little bit easier. So this will be 2x over 1 squared minus 1 equals 2x squared minus 1. And that's our answer. Next, we're going to look at 22. It says sine of sine inverse u plus sine inverse v. Again, I'm going to name this as alpha and beta. The only difference is that alpha and beta will not correspond to standard angles because we don't know what u and v are. So I have u over 1 and v over 1. Using Pythagoreans, I can find my remaining sides. And then I'm going to use our addition formula for sine from the last video to break up our sine here. So we have sine of sine inverse u, cosine of sine inverse v, plus cosine of sine inverse u times sine of sine inverse v. By properties of inverses, this first sine of sine inverse of u is just going to be u. Cosine of sine inverse of v is going to be square root 1 minus v squared, because it's adjacent over hypotenuse, which is 1, plus cosine of sine inverse of u is going to be square root 1 minus u squared. And by properties of inverses, sine inverse of v is going to be v. So I get u square root 1 minus v squared plus v square root 1 minus u squared. The second lesson is just really a continuation of the first, in that now we're going to look at all the other inverse functions. So we have 6 trig functions, so we have 6 trig inverse functions. So using the same kind of idea where we break up and we only look at a certain domain, x is equal to tan inverse y if and only if tangent x is equal to y. So this is saying that if tangent of that angle is equal to some value, then the angle is equal to tan inverse of that value. And x, your angle must be between negative pi over 2 and pi over 2, not inclusive. And then goes for the same thing for cotangent. So we've got x equals cotangent inverse y if and only if cotangent x is equal to y and 0 is less than x is less than pi. And then secant inverse of y is equal to cosine inverse of 1 over y, and cosecant inverse of y is equal to sine inverse of 1 over y if the absolute value of y is greater than or equal to 1. So this is just so that we don't get stuck with zeros and such, but they do follow the same rules as sine and cosine for secant and cosecant. Okay, so let's look at examples. In 6, we have tan inverse of tangent of 11 pi over 6. So by inverse properties, we know this is going to be 11 pi over 6. Our issue, though, is that 11 pi over 6 is much larger than pi over 2. So it's not in the interval. So we need to make it in the interval by subtracting pi over 2 to get a coterminal angle that is in the interval. And so this is 11 pi over 6 minus 12 pi over 6. So this is negative pi over 6, which is in the interval. For 10, we want sine of cosecant inverse of 3. By definition of cosecant inverse, which if you forgot, it's right up above, is just sine of sine inverse 1 over 3. So then by definition of inverses, this is just 1/3. And 1/3 is inside our interval, so we're good. Now let's look at 16. We have cosine of tan inverse 4/3 minus sine inverse 5/13. So first thing I need to do, didn't mean to zoom in that far, is figure out my triangles. So we've got tan inverse of 4/3, so I'm going to call that alpha, and sine inverse of 5/13, I'm going to call beta. So using tan inverse to find the rest of my alpha, I know I'm in quadrant 1 because it's positive, and I've got opposite over adjacent. Using Pythagoreans, this is just going to be 5, right? Because it's 9 plus 16 is 25. Square root of 25 is 5. For beta, I have sine is positive, so we're in quadrant 1. I have the opposite over hypotenuse. This is a Pythagorean triple, so this is 12. Okay, knowing this, I'm going to then rewrite as cosine of alpha minus beta. This fits my addition formula for cosine from the very first lesson of this section. So I get cosine of alpha, cosine of beta, plus sine of alpha, sine of beta. Cosine of alpha is adjacent over hypotenuse, so that's 3/5. Cosine of beta is adjacent over hypotenuse, so that's 12 over 13. Plus sine of alpha is 4/5. And sine of beta is 5/13. So this will then simplify to 36 over 65 plus 20 over 65. So this will be 56 over 65. For 18, we need to find tangent of 2 cosine inverse of negative 3/5. So what we're really looking for is tangent of 2 theta. So I'm going to draw my triangle representing theta. I am in the second quadrant because cosine is negative here. So I've got negative 3 and 5, and by Pythagoreans, my remaining leg is 4. So then tangent 2 theta, we don't actually have a given formula for it. So what I'm going to do is use identities to make the sine 2 theta over cosine 2 theta, which is equal to 2 sine theta cosine theta over 2 cosine squared theta minus 1. And then I'm going to plug in. So I have 2 sine theta is 4/5. Cosine theta is negative 3/5 over 2, and then negative 3/5 squared minus 1. So after all the multiplication, I get negative 24 over 25 in the numerator, and 18 over 25 minus 25 over 25. So this is negative 24 over 25 over negative 7 over 25. So this will be 24 over 7. For 22, we want to find sine of cotangent inverse of x. So first thing I'm going to do is draw a corresponding triangle. So I'm looking for here sine of the same theta. So we have our theta. Cotangent x is adjacent over hypotenuse. Adjacent over opposite. So this is x and 1. So I'm left with x squared plus 1 underneath the radical for my hypotenuse using Pythagoreans. So then sine theta is going to be 1 over square root x squared plus 1. I cannot leave that in the denominator, so I'm going to rationalize up. And I get square root of x squared plus 1 over x squared plus 1. For 24, we have cosine of 2 cotangent inverse of x. My triangle is exactly the same as it was in the previous problem, so I'm just going to copy it. What's different is what I'm asking for. I'm being asked to find cosine of 2 theta. So this is going to be 2 cosine squared theta minus 1. You can use any of the other ones if you so desire for the cosine 2 theta formulas. I'm going to plug in my cosine, so I get 2x over square root x squared plus 1 quantity squared minus 1. This is 2 times x squared over x squared plus 1 minus 1. So this is 2x squared over x squared plus 1 minus 1. Common denominator is x squared plus 1, so this is 2x squared minus x squared plus 1 over x squared plus 1. So this is 2x squared minus x squared minus 1 over x squared plus 1. So this is x squared minus 1 over x squared plus 1. Lastly, we're going to look at 26. We want to find cotangent of tangent inverse x minus tangent inverse y. So again, first thing I'm going to do is I'm going to label tangent inverse x as alpha and tangent inverse y as beta. And I'm going to draw corresponding triangles. So I've got alpha and beta. Both these triangles are in quadrant 1 because both values are positive, x and y. I've got opposite over adjacent for each. So I'm going to fill that in accordingly, and then fill in my hypotenuse using Pythagoreans, like so. So then I'm going to rewrite what we're looking for as cotangent of alpha minus beta. We have a slight issue though because we don't have a formula for cotangent, so I need to rewrite this with identities as cosine of alpha minus beta over sine of alpha minus beta. And then I'm going to write each of these out using its addition in some formula. So this will be cosine of alpha, cosine of beta, plus sine of alpha, sine of beta, over sine of alpha cosine of beta plus cosine alpha, sorry, not plus, minus sine of beta. So this then, I'm going to plug in everything I have. So cosine of alpha is 1 over square root 1 plus x squared. Cosine of beta is 1 over square root 1 plus y squared. Plus sine of alpha is x over square root x squared plus 1 times sine of beta, which is y over square root y squared plus 1, all over sine of alpha is x over square root 1 plus x squared times cosine of beta is 1 over square root 1 plus y squared minus cosine of alpha is 1 over 1 plus, square root of 1 plus x squared, and sine of beta is y over square root 1 plus y squared. I'm going to then multiply each of these out. So I get 1 over the square root of 1 plus x squared times 1 plus y squared plus xy over square root of x squared plus 1 times y squared plus 1 all over x over square root 1 plus x squared 1 plus y squared minus y over square root 1 plus x squared 1 plus y squared. Denominators are all the same in each portion of the fraction, numerator and denominator, so I'm just going to combine. So I have 1 plus xy over square root 1 plus x squared 1 plus y squared all over x minus y over square root 1 plus x squared 1 plus y squared. I'm then going to divide these fractions with each other, so that means I'm going to multiply by the reciprocal. So I have 1 plus xy over square root 1 plus x squared 1 plus y squared times square root 1 plus x squared 1 plus y squared over x minus y. Denominator here and the numerator there cancel, so I'm left with 1 plus xy over x minus y. And that's my answer. And that's the end of the video, okay? So classwork, due dates on calendar is page 692, the oral exercises 1 through 8 all, and the written exercises 1 through 23 odd. If you want to double check some of your answers, for the finite ones, so for oral, you can plug it into your calculator and make sure you got the right answer, but you need to be able to do it without a calculator for the test. And page 695, numbers 1 through 25 odd on the written exercises. As a quick reminder, in case you haven't been looking at your calendars recently, your final test of the quarter will be the 19th for F block, and then C block will break it up. Part 1 will be the 18th, and Part 2 will be the 22nd.